Hello all, in continuous with the previous lecture, in this lecture number 3, we will study today binary arithmetic operation in the digital logic design subject. So basically you have to study 4 mathematical operations. First is addition, second subtraction, third is multiplication, and fourth is division. So these 4 operations you have to perform using binary numbers. So let us begin with it. So first of all, you have to know the rules of all the mathematical operations. Here what logical you should apply for this, because we are using binary numbers. So first we take is addition. So what is the rule for binary addition? So suppose you are given two numbers A and B. So for various combination of A and B, 0 0 1 0 0 1 1 1 and 3 times 1, we will perform addition of these bits. So let us take first combination, that is 0 0. So 0 plus 0, that will give addition as 0 and carry as a 0. Here two terms are there, sum and carry. So if any summation is beyond the 1, then carry will be set to 1, that we will see in the next case. So here for 0 plus 0, sum will be 0 and carry will be 0, that you have to remember. Next is 1 plus 0, so that will give sum as a 1 and carry 0. Next case 0 plus 1, that will give sum 1 and carry 0. Next 1 plus 1, so that will give sum as a 0 but carry as a 1. You have to remember this when 1 plus 1 is there, right? 1 plus 1 is there. So sum will be 0 and carry will be 1. Next 3 times 1 you have to add. Then first of all you have to add first 2 bit, yani ki 1 plus 1, and the answer of that should be added to next 1. So when 3 1 are there, then its sum will be 1 and its carry will be also 1. So these two cases you have to remember, that are most important while doing any of addition of numbers. So please remember this table. This table will be very useful for the example. So now let us take one example of this. Here you are given to add two numbers. First is 1 1 1 1 0 1, and second number is 1 0 1 1 1 1 and 2. These two numbers are given to addition. Right hand side 61, 23 and 84 are given the decimal equivalent of this binary number, that are for the cross check purpose. So right now we will start addition bit by bit. So here we will start from the right hand side. First bit of first number is 1, first bit of second number is 1. So remember that table. If we add 1 plus 1, so sum will be 0 and carry will be 1, so it is forwarded here. Okay, now in the next 1 plus 0 plus 1, so again 1 plus 1, So that will give sum as a 0 and carry will be forwarded here. Okay. Now 3 times 1 is there. So its sum will be 1 and carry will be 1, that is forwarded here. Next 1 plus 1, that will give sum as a 0 but carry will be forwarded here. Now 3 times 1, so it will give sum as a 0 and carry is forwarded here. So 1 plus 1 give sum as a 0 and carry is forwarded here, and this is drop down here. So in this manner you can find out addition of any binary numbers using this binary addition rules. So remember that you have to must remember binary addition rules table, and then you have to apply in any of the example you can solve very easily. So by converting it into decimal, you can cross check your answer. 61 plus 23, it will give 84. So this is the binary equivalent of 84, right? So this is very simple. Now let us see binary subtraction rules. So in the binary subtraction rules, first combination is 0 0. If 0 minus 0 is there, then now here two terms are there, difference and borrow. So difference will be 0 and we have not taken any borrow, 0 minus 0, so borrow is 0, right? Here remember that a minus b is there, a minus b, not b minus a. Okay. Next combination 1 minus 0. So 1 minus 0, obviously difference is 1 and borrow is 0. 1 minus 1, then difference is 0 and borrow is also 0, right? Now last case, that is most important, 0 minus 1. Here we are subtracting small values, bigger value from the small value. Okay, so in this case we will have to take borrow. So here borrow will be 1 and difference will be 1. See, if we subtract 0 minus 1 or 1 minus 0, so basically difference will be 1. So in that manner here 1 is given in difference, right? But we have to take 1 borrow. Please remember this table because this table will be used for the subtraction. Now let us take one example of this. First number is given 1001101 and second number is given 10111. Now we are asked to subtract this two binary numbers. So let us start. Starting from the left side, first bit 1 1. So 1 minus 1 give 0. Okay. Next 0 minus 1. So remember that table, 0 minus will give difference 1 and borrow 1. But here 1 is not taken, but whatever bit is available in the next, just opposite of it you have to write here for the calculation. So here 1 is given, so its opposite is 0. So 0 you have to consider. So 0 minus this 1 will give difference as a 1. But again next stage you have to take borrow. So for borrow here 1 is given, take opposite of it, that is 0. Now subtract this 0 and this 0. so it will result in the 0. But here one borrow is taken and it is completed, right? Now in the next combination 0 minus 1 is there. So you know the rules, 0 minus 1 is 1 and you have to take here borrow. So 0 is here, so you have to take 1 here as a borrow. So this one is taken here 1. Okay. Now here one borrow is also needed to take, because here we have taken one borrow that is not completed here. So again take one borrow, this one will become 0 and this 0 is taken here. Okay, so in this manner you can find out subtraction of any binary numbers easily. So you have to remember binary subtraction rules for subtraction. Now suppose any subtraction is asked in the decimal point form, then also you can easily subtract it using that rules. For example, you are asked to subtract this number from this number. Okay, so don't make mistake. After the from whatever number is given, that will be first number and this number will be second number. Second thing that you have to remember is that you have to put second number and first number, both position of decimal point should be at one position. That means both should be matched. You cannot write from right hand side of left hand side. Two decimal point must be matched. Okay, after this step you have to perform as usual subtraction rules to subtract these binary numbers. So here let us start with that. Starting from right hand side, this one is as it is. Next is 0 minus 1. You know the rules, borrow is will be there, right? So here 1 become 0. So 0 minus 1, again difference is 1, but you have to take borrow. So 1 minus 1, it will be 0, but here you have to take 1 borrow, because in previously we have subtracted from bigger value from smaller value. So 1 minus 1 here will give 0. Again we have to take here borrow. 0 minus 1 will give 1. We will take borrow here. 1 minus 1, it is 0. Again take the borrow. 0 minus 1, difference is 1. Again have to take the borrow. So that is 1, and 1 minus 1, it will give answer as a 0. And lastly take borrow, so that 0 will be here. If you don't write, that will be fine. Okay, so in this manner this subtraction is being processed, right? So after subtracting these two numbers, you have to put decimal point. So exactly in the answer put the decimal point where in the two numbers you have matched. Okay, so final answer of this subtraction will be 0, 1, 0, 1, 0.0111. and don't forget to write here base 2. It indicates binary, so without it your answer will be wrong. Okay, so please remember these rules for the binary subtraction. Now is third operation, that is binary multiplication. All of you know that if we multiply any any number with 0, so it will give answer as a 0. So same rule is applied here. So see, in the first three combination 0 0 0 1 and 1 0, here at least 1 0 is there. Okay, so all these three have answer 0. Only last combination is 1 1, so its answer will be 1. Simple. Multiplication rule is very simple. Now let us take its example. Here two numbers are given. First number is 1011 and second number is 1010. You are asked to multiply these two numbers. You have to perform multiplication bit by bit. Now remember that if first number is multiplied with 0, then it will produce only zeros of total bits it is given, and if it will multiply with 1, it will give as it is number is given. Okay, so let us start with multiplication with first bit. So first bit is 0, so 1 2 3 4 and 5. This 5 bit will be multiplied with this 0 and it will generate 5 zeros. So that you have to put exact below to the numbers in this position, exact below. Okay. Next, this one bit is multiplied with each bit. So it will produce as it is 10111 as it is given here. Okay, but here you have to make one space. Every time you make multiplication of one bit, you have to put one space. So after that you have to start writing this one is here, this one is here, this 0 is here, and this one is here. Okay. Next is a third bit turn. It is 0. So here 5 zeros will be there, but you have to put here 2 times space. 5 0 are there. Okay. Fourth bit, put 3 space here and put first number as it is. If next bit is given, so here what you have to do, again next put fourth space and so on. Okay, you have to put all this in this position manner only, don't change this position. Now you have to just do addition of all this bit by bit. So first 0 as it is, 0 plus 1 1, 0 1 0, that is 1, 0 1 0 1 addition is 0 because here 2 times 1 are added, so sum is 0 but carry will be 1 here. In the next, this one and this one will give sum 0 but carry will be forwarded. 3 times 1, that will generate sum 0, 1 carry is forwarded. This one is written here and this one is written here. Okay, so in this manner final answer of this multiplication is 1 1 1 0 0 1 1 0. Simple. Okay, and you have to write base as a 2 after multiplication. Now suppose any decimal point multiplication is given, fractional multiplication is given. So how will you do it? So let us take its example. So first, as I have said, match these two decimal point, these two numbers decimal point. Now do multiplication in simple way without decimal point. That means first of all this one bit will be multiplied with this number. So this one is written here, one is here, that means same you have to write here. Okay, without decimal point. Next, this 0 will be multiplied, so it will generate how many bits? 1 2 3 4 5 and 6. So after putting one space, 6 times 0 are written here without decimal point. Third bit, 1 is multiplied, put here 2 space and put first number as it is, right? Now do just simple addition of this. So in addition, this one as it is, 1 plus 0 1, 2 times 1 is 0 and carry is 1. This one and this one generate 0 and carry will be forwarded here 1, here 1 1 and 1, 3 times 1 is there, so sum is 1 and carry is forwarded here. Now 1 1 2 times, so sum is 0, carry is forwarded here. So this one and this one will give sum 0, carry is forwarded here, and 1 plus 1 that will give sum 0 and 1 is carry is forwarded, it is taken here. Okay, so while doing multiplication you can write separate space for carry for calculation easily, right? Now you know the multiplication and its addition, right? Now the point is where to put decimal point. So that is most important thing. Listen carefully. Here see in the first number after decimal point how many bits are there? 2. And in the second number after decimal point how many bits are there? 2. So 2 plus 2 will be 4. Okay, so in the final answer starting from right hand side 1 2 3 and 4 you have to put decimal point. After 4 bit you have to put decimal point, just simple. Okay, so that will be your answer. So that you have to calculate that after decimal point in the first number and in the second number how many decimal points are given, how many bits are given, so that you have to use in the answer. Okay, now let us study last operation, that is binary division. So in the binary division, if we divide 0 by 1, so it is 0, 1 divided by 1 it will be 1, and 1 divided by 0 that is not allowed. So remember these rules. Let us take one example of it. Here you are asked to divide this term 1 1 0 1 1 0 1 1 by 1 0 1. So put first number here and second number here. Okay, so as we do in the decimal, here you have to take 1 or 0 as the multiplication factor with the second number. So first of all, 101 will be multiplied with 1. So here put first one and write down here 101. Now do subtraction of it. 1 minus 1, that will give 0. Okay, here you have to consider 0. Here you have to consider 0. Here it is 1 1 0 and 1 1 0. It is taken. So for that 0 minus 1 will give borrow 1, so that is forwarded here. So here you will get 1 0 0 1 after subtraction. So here for the next process we will drop down this one as a here, but you can see that here 0 1 1, that is a smaller value compared to 1 0 1. So here 1 0 is taken and another one is taken here. Okay, now subtract these terms from 1 0 1 1 1 and 1 0 1. So that will be some answer. 1 minus 1, that will give 0, 1 minus 0, that will give 1, and 1 minus 1, that will generate 0. Simple. Now this 1 0 0, next we are taking next 0 here, but again this 1 0 1 is bigger, so again take next 0 here and take 1 here. Now subtract this and 1 0 1, so it will generate 1 0 0. So again 1 0 0 is small value compared to 1 0 1, and last one we will take here and multiply this 1 0 1 with 1, so it will give 1 0 1. So subtraction of 1 0 1 and 1 0 0 1, that will produce 1 0 0. Now here no any digits are available, so we cannot go further, right? So this will known as a remainder, and whatever things are here, it is quotient. Okay, so you can cross check it by converting this binary number into decimals, right? Here one mistake is there. Here you have to consider this number 1 1 0 1 1 0 1, but don't worry, you have to just follow the rules that are given and steps that are given here. You will find this answer, right? So in this manner you can find out a division of any binary numbers, and you have to write in the answer quotient and remainder. Okay, so these were the basic operation of binary numbers: addition, multiplication, subtraction and division. So we will see next topic in the next lecture. So for till that you have to write this assignment and submit it before the deadline. Thank you.